For our next unit, we're going to start quadratics, and we're going to start by graphing quadratics. So we have two different forms we're going to look at. One of them is called vertex form. So first of all, what is a quadratic? Well, it's a second-degree polynomial. Okay, you can have a quadratic that's a monomial, a binomial, or a trinomial. Right? It's always going to have an x squared in it. Okay, that's how you know if it's a quadratic, because the highest exponent is a 2. Okay, the graph, whenever you graph a quadratic, it makes a U-shape, and we call that U-shape a parabola. So our parent function is y equals x squared. So that's like the most basic quadratic we have, and every other quadratic is some transformation of this parent function. So if we think about graphing this parent function, right, if I make a table, just make an xy table, I'm just going to do the same points that we did for our exponential equations, -2 to +2. So -2 squared would be -2 times -2, which is +4. -1 squared would be a +1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So if I graph that, I have -2, +4, -1, 1, 0, 0, 1, 1, 2, 4. Okay, so this is the most basic quadratic that we have. If you notice, right, 0, 0 is the middle of the graph, right? Everything's symmetrical on both sides. So if I were to draw a dotted line down the middle, this is called the axis of symmetry. This is the very middle of my graph. The point that's on that axis of symmetry, the very middle point on the graph, is called the vertex. Okay, that is a very important point anytime we graph a quadratic. So you have to make sure that you're able to find the vertex. Okay, from the vertex to get to our second points, we go up 1, right 1, up 1, left 1. And then we go up 4, right 2, up 4, left 2. Pay attention to that relationship. We're going to come back to that in a few minutes. Vertex form of a quadratic is a times the quantity x minus h squared plus k. Now we've seen a, h, and k before when we did our exponential functions. It's the same a, h, and k. So remember, exponential was ab to the x minus h plus k. Right? That a still tells us if it's negative, that means it's reflected, so it's going down. And then a can be bigger than 1, or it can be between 0 and 1. If it's bigger than 1, we're making the graph skinnier, and we call that stretching. If it's between 0 and 1, it's getting fatter, so we're compressing. Now remember, that is always stretching, compressing vertically. So you're either pulling up on it, making it skinnier, or you're pushing down, making it flatter. The h is our horizontal translation. So we're taking that parent graph and we're going left to right. And remember, it's always the opposite sign. Okay, this is the same exact h and k from exponential. And then k is our vertical translation. And it keeps the same sign. Now we call this vertex form because it's going to give you the vertex right off the bat. So the vertex is always going to be h comma k. And that's why we call it vertex form. It makes it very easy to get that important point on your graph. So graphing in vertex form. To start with, we're going to find the vertex. So if I look here, my h is a +2 because it's a -2 in parentheses, opposite sign. So my h is a +2, and then my k is on the outside, +3. So that means that my vertex is at 2, 3. There's the very middle of my graph. Now remember, on that vertex was the axis of symmetry, or the vertex was on the axis of symmetry, which is the very middle. So if you were asked to just find the axis of symmetry in vertex form, it's always going to be the h value. Okay, now this is a dotted line, so it's not just a number, it's an equation, and we have to have an equal sign in our equation. So a vertical line is always x equals. So this would be x equals 2 in this case, would be our axis of symmetry. Okay, so now that was h and k. So if I think about this a of 2, that's telling me that it's being stretched by 2 and that it opens up because it's positive. So I didn't reflect my original parent graph that was a normal U shape. Okay, so now we're going to make a table for this one, but then we're going to see kind of a cheat. So if I make that same table with those 5, now I'm not choosing the same exact 5 points, but I'm going to choose 5 points that are kind of centered around my vertex here. So maybe, 0, 1, 2, 3, 4, and use those points instead. So if I plug in 0, 0 minus 2 is negative 2. Negative 2 squared is positive 4. 4 times 2 is 8. And 8 plus 3 is 11. Right? If I plug in 1, 1 minus 2 is negative 1. Squared is positive 1. Times 2 is 2. Plus 3 is 5. 2 minus 2 is 0. 0 squared is 0. 0 times 2 is 0. Plus 3 is 3. And then 3 minus 2 is 1, squared is 1, times 2 is 2, plus 3 is 5, and we have our pattern, so we're back up here at 11. Right, so now if I fill those in, it's going to go way off my graph, but that's okay. Let me get back to blue. I've got 0, 11, so there's 3, 4, 5, so we'll say 6, 7, 8, 9, 10, 11, way up here. Okay, then we've got 1, 5, which is right here, and then over here, and back up to 11. And there's my U-shaped graph. Now, obviously, some of these are going to get really big really quickly, so we really only need 3 points to be able to see where our curve is, as long as we have the vertex included in those points, right? But if you notice, before, let's go back to that slide, before we went up 1, right 1 to get to the first point. Now, in this one, because I stretched it by 2, I went up 2, right 1. Okay, so I went up double. Then, when I went to the second point, I went up 4, right 2. Now, I go from 3 to 11, which is up 8, right 2. So if you notice, I have that same pattern, but now I'm going up double because of my 2. I'm stretching it twice as much. Okay, so our cheat is we don't necessarily need all 5 points. We really just need 3, the 3 middle ones here. So I could have found my vertex, and then because it's a 2, gone up 2, right 1, instead of up 1, right 1. So let's do another one. I want to find the vertex of this one. So my h is a negative 1, and then my k is a negative 1. And we got a little typo, forgotten the squared. So I can go negative 1, negative 1. And that's the middle of my graph. That's where my axis of symmetry is. And then I can use my negative 1/2 to find my other points. Now this negative tells me that it's going down. So now instead of going up 1, right 1, I'm going to go down 1, right 1. And then the 1/2 tells me that it's compressed. So I'm going to go half as much. So instead of going down 1, right 1, I'm going to go down 1/2 and right 1 and put my point. Then I'm going to go down 1/2 and left 1, put my point. And there's my 3 points, so there's my exact graph. Okay, the other thing we need to talk about, just add on here, is that we have domain, range, and a y-intercept. Those are common questions. So the domain, if you think about where you have x values for this u, or any u, it's going to keep going to the left forever. And it's going to keep going to the right forever, which means my domain is all real numbers. For every single quadratic, all real numbers. The range is going to change based on whether it opens up or down and whatever your vertex is, because your vertex is the highest or the lowest point. So in the one we just did, it was the lowest point, right? The graph comes down and then it stops and goes back up. For this one, it's the highest point. It's a maximum because it comes up and then it goes back down. So for this one, both of my arrows are pointing to negative infinity. So I'm going to have a negative infinity in my range. Remember, negative infinity always goes on the left-hand side. Then my graph comes up, 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 and it stops at negative 1 on the y-axis. So I'm going to stop at negative 1, and I have a value there, right? No asymptote, so I'm going to put a bracket. Okay, to find your y-intercept for any graph ever, you plug in 0 for x. So if I plug in 0, 0 plus 1 is 1, squared is 1, times negative 1/2 is negative 1/2, and then negative 1/2 minus 1 is negative 1/2. So my y-intercept is at 0, negative 1.5, right, which is where I put mine. So if we do those same three things for the first example, okay, your domain, every single time, all real numbers. It's never going to stop going left and right. Your range, in this case, my arrows are pointing up, so I have a positive infinity, which always goes on the right-hand side. And then my minimum, the lowest point, is at 3 on my y-axis, and we always use a bracket. My y-intercept, I plug in 0 for x. 0 minus 2 is negative 2. Squared is positive 4. Times 2 is 8. Plus 3 is 11. So my y-intercept is at 0, 11, which is also where we found it to be in our table. Okay, so domain is always all real numbers. Range is based on if it goes up or down, and it's whatever the vertex is, specifically whatever your k value is. And then your y-intercept, you're just going to plug in 0 for x every single time.